In this episode, we focus on the part of exam preparation that often gets misunderstood, especially by brand new learners. Tactics are not tricks, and they are not a substitute for learning, but they can dramatically improve your performance when they are built on solid thinking. Many people assume that passing an advanced certification requires memorizing large amounts of information and hoping the right facts appear on test day. ISSEP is different because it is aimed at security engineering judgment, which means it often rewards the ability to interpret a situation, recognize what kind of decision is being tested, and select the most defensible option under constraints. That is great for learners who like understanding more than rote recall, but it can also feel confusing because the questions may present several answers that sound correct. The goal here is to give you a dependable way to think through questions so you can succeed even when you do not feel like you have a perfect memory, because your reasoning becomes your most reliable tool. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. The first mindset shift is to treat each question as a small decision document rather than a trivia prompt. In real security engineering, decisions are rarely made by recalling a single fact. They are made by considering goals, constraints, stakeholders, and evidence, and then choosing a path that you can defend. Exam questions are written to simulate that kind of thinking in miniature, using limited text and a set of options. When you approach a question this way, you naturally start looking for the decision being asked, not just the keyword. This prevents a very common mistake where learners see a familiar term and immediately choose an answer that matches that term, even if the question is asking something different. A decision mindset also makes you less vulnerable to distractors, because distractors often contain true statements that are not the best decision for the scenario. If you can explain why your chosen option is the most defensible decision, you are doing what the exam is designed to reward. A practical tactic that fits this mindset is to identify the question type before you evaluate the options. Some questions are asking for a best next step, which is about sequence and process. Some are asking for the best explanation or rationale, which is about justification and engineering reasoning. Some are asking for the most important consideration, which is about prioritization under constraints. Others are asking for the most effective control or approach, which is about matching a solution to a problem and a context. If you name the question type in your head, even silently, you create a filter that keeps you from answering the wrong question. For example, if it is a best next step question, you should be suspicious of options that describe long-term improvements when the immediate step is missing. This tactic does not require memorization. It requires attention to what the question is asking you to do. Once you know the question type, the next tactic is to restate the scenario in plain language, focusing on what must be true. This is important because exam scenarios can include extra details that feel important but are not actually the driver of the decision. A useful approach is to identify the system context, the primary objective, and the main constraint. The system context might be something like a critical service, a distributed system, or a regulated environment, and it shapes what solutions are realistic. The primary objective might be to reduce risk, increase assurance, prevent a specific failure mode, or ensure accountability, and it tells you what success looks like. The main constraint might be limited time, legacy components, mission demands, or a need for strong evidence, and it tells you what you cannot ignore. When you restate those three elements to yourself, you are building a clear frame for evaluating options, and that frame is far more powerful than trying to remember a list of facts. A tactic that works especially well on ISSEP-style questions is elimination based on mismatch, because many wrong options are wrong for a specific reason, not because they are always bad. Start by removing answers that do not address the objective, such as improving confidentiality when the scenario's main risk is availability. Then remove answers that violate the constraint, such as proposing a redesign when the situation demands an immediate mitigation. Next, remove answers that are at the wrong level, such as a very specific technical measure when the question is clearly about engineering process or governance. Finally, watch for answers that feel like slogans, because they may be true in general but not actionable or appropriately scoped for the question. Elimination is not about being negative. It is about clearing away noise so you can see the real competition among the remaining options. This technique depends on understanding and framing, not memorization, and it becomes faster with practice because you start recognizing common mismatch patterns. When you get down to two plausible answers, the exam is often testing fine distinctions that matter in engineering. At that moment, a useful tactic is to compare the options on scope, sequencing, and evidence. Scope asks whether the option addresses the system broadly or only a small piece, and whether that matches what the question wants. Sequencing asks whether the option is the right time, such as whether it should happen before design, during implementation, or during verification. Evidence asks whether the option produces confidence you can justify, such as documentation, traceability, testing results, monitoring signals, or auditability. The best answer often has the right scope, happens at the right time, and creates usable evidence. Because security engineering is not just doing controls. It is being able to prove that the system meets its intended security requirements. This comparison step feels like a mental tiebreaker, but it is actually core engineering reasoning, and it is something you can do even when you do not remember every detail of standards or frameworks. Another tactic is to look for the most fundamental engineering move, because many questions can be answered by choosing the option that stabilizes the situation at the root rather than patching symptoms. For example, if a scenario indicates repeated security failures due to unclear requirements, the fundamental move is often to fix requirements and traceability rather than adding more controls at the end. If the scenario suggests weak accountability and inconsistent decision-making, the fundamental move may involve clarifying authority, roles, and governance, because that shapes every downstream action. If the scenario indicates uncertain security posture due to lack of evidence, the fundamental move may focus on assurance activities that generate confidence, not just on adding features. This is not a rule that always applies, because sometimes immediate mitigations are needed, but it is a strong instinct for ISSEP because the certification emphasizes engineering foundations. When you can recognize what is fundamental in the scenario, you avoid being distracted by options that feel busy but do not change the underlying security reality. You should also expect questions that test trade-offs, because security engineering is rarely about maximizing everything at once. A strong tactic here is to ask what the scenario values most, since constraints often imply priorities. If the scenario involves a safety-critical or mission-critical system, availability and integrity might be emphasized, and choices that risk downtime may be less defensible. If the scenario involves sensitive data and strong regulatory oversight, confidentiality and auditability might be emphasized, and choices that cannot be justified with evidence may be weak. If the scenario involves complex integration across components, architectural boundary decisions and interface controls may be emphasized, because that is where predictable failure modes often emerge. When you identify implied priorities, you can evaluate options by asking which one protects the highest priority objective without causing unacceptable harm to others. This is how engineers think, and it is also how many exam questions are constructed. A common misconception is that the best exam tactic is to look for keywords that map to a known answer, but keyword hunting is risky on an engineering-focused exam. Keywords can help you recognize the topic area, but they do not tell you what decision is being asked. For example, seeing a word like trust might tempt you to choose an answer about trust models, but the question might actually be about defining boundaries, managing interfaces, or collecting assurance evidence. Another keyword trap is choosing the most advanced-sounding option, assuming complexity equals correctness. In engineering, overly complex solutions can introduce new risks and can be harder to assure, so the best answer is often the one that is appropriately simple for the objective and constraints. A better tactic is to use keywords to orient yourself, then return to the framing step and evaluate options against the objective. This keeps your thinking disciplined and reduces impulsive choices. Because you are not relying on memorization, you need a tactic for dealing with unfamiliar terms or a scenario that feels outside your experience. The key is to fall back on principles and reasoning. Ask yourself what the question is trying to measure. Is it about controlling interfaces, ensuring least privilege, preventing single points of failure, establishing accountability, or producing evidence of compliance with requirements? Then choose the option that best aligns with those principles, even if some details feel new. Most exams are designed so that the correct answer can be chosen through sound reasoning, not hidden knowledge, because the credential is meant to represent professional judgment. When you stay calm and use a principle-based approach, unfamiliarity becomes a manageable obstacle rather than a disaster. This is also why practicing explanation in plain language is so valuable, because you can reason your way to an answer by explaining what must be true for the system to be secure. Another tactical skill is managing your own mental state during the exam, because stress can make you misread questions and ignore constraints. A simple approach is to treat each question as independent, so a hard question does not poison the next one. If you feel stuck, shift from searching for the perfect answer to eliminating clearly wrong answers and choosing the best remaining option. This keeps you moving and preserves time for questions you can answer more confidently. It also helps to remember that feeling uncertain does not mean you are doing poorly. It often means the question is well written and is testing judgment. Engineers routinely make decisions under uncertainty, and that is part of what the exam is measuring. When you accept uncertainty as normal, you reduce panic and keep your reasoning process intact. To build these tactics into habit, you want to practice in a way that matches how your mind will work under time pressure. The best practice is not memorizing phrases, but rehearsing the reasoning steps until they feel natural. You can do this by taking any concept you learn and imagining how it could become a question that forces a choice. Then you practice the cycle. Identify question type, restate objective and constraint, eliminate mismatches, compare remaining options on scope, sequencing, and evidence, and choose the most defensible decision. Over time, this becomes your default mode, and it speeds up because you no longer have to invent a method in the moment. This is why tactics matter. They turn thinking into a repeatable process. When your process is repeatable, you do not need to rely on memorization to feel confident. As a final wrap-up, remember that mastering exam tactics without memorizing is really about building a stable way of thinking that travels across every domain. The exam is not asking you to be a walking glossary. It is asking you to demonstrate security engineering judgment by interpreting scenarios, honoring constraints, and choosing defensible actions that align with principles and evidence. The tactics you learned here work because they start with understanding what the question is asking. They force you to frame the scenario clearly, and they guide you to eliminate wrong answers for concrete reasons rather than for vague feelings. When you compare close options using scope, sequencing, and evidence, you are thinking like an engineer who must justify decisions, not like a student hoping to recognize the right phrase. If you keep practicing that reasoning cycle as your primary study skill, you will find that your confidence grows even when your memory feels imperfect, because your method becomes the reliable foundation you can count on.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.